Hello everyone, welcome back. So in the last video for this week, we're going to get some extra practice working with for loops in particular, and we're also going to talk about the map function. Map and for loops are going to work really well together. They're going to allow us to take the loop counter that we create and manipulate it inside our for loop in interesting ways. So let's do an example to explain what this means. All right, so I've already created a new sketch here, and I'm going to also add the window resized event, resize canvas. We talked about that in the first video this week. Window height, it's going to come in handy, and let's throw these in as well really quickly. And hit play. All right, so let's get some practice with the for loop. Okay? And for this example, we're going to use the for loop to draw a sequence of circles across the screen. And we're going to draw all of these inside draw here within one single frame. Okay? So we're going to set up our for loop. Initially, we'll just have the counter go from 0 to width, and we'll see what that looks like. So as we've seen, the for loop, we set it up like this. Okay, we're going to use the keyword for, and then inside the parentheses, we're going to have three ingredients. We're going to have the counter, the condition, and the increment. Okay? So let's say we wanted to have a loop that's going to repeat. It's going to count from 0 to width, okay, which is the number of pixels we have in our screen. So that's going to be our first number of repetitions. We would set it up like this. So we would create a variable to become the counter. Now, in the previous example, we used the word counter as our variable, which is fine. But most of the time, we're going to use the keyword I for loop counters as kind of a convention. The reason for that will become clear next week when we talk about arrays. But for today, we're just going to use the letter I, basically treat it as a variable like X or Y. It just is it's shorter, and it's going to make our lives a little easier when we're programming. So we're going to call our loop counter I, and we'll say as long as I is less than width, we want to repeat this for loop. And to start with, we are going to put increments of 1. Okay. And here, because I have auto refresh on, see, I've created this infinite loop situation. And this is what happens. Okay, so it says, oh no, unresponsive. So we're going to exit and refresh. Okay. So good idea to turn off auto refresh when you're writing loops. So we'll say as long as I is less than width, we're going to increase in in steps of 1. Okay. So disable auto refresh so we don't accidentally create a infinite loop condition. And what we'll do inside this for loop is we are going to use the counter. So we're going to use the variable I to draw an element in our window, kind of spreading it across the side of the window. And just to make things very clear, normally I wouldn't bother with this, but we're going to create intermediate variables to make it very clear that the x coordinate for our circle is going to be the value I. We're going to center the circle vertically, so we'll let y equal to height divided by 2. And then we're going to draw a circle using these variables. Okay? And let's define a diameter as well, just so we're like being very, very explicit here about what we're doing. And hit the play button. Okay. So we can see this is what the loop is doing, right? It's taking this body of code here, and it's repeating it based on how we've set up the conditions for the loop. So right now we've told it to basically repeat as many times as we have pixels in our window. So it goes from 0 to width, and we can see the circles being drawn all very, very close to each other. Okay? If we wanted to spread them out a little bit, we could change the increment, for example. We could say instead of incrementing by steps of 1, I'm going to increment by steps of 50. And then hit refresh. And now we can see we're starting from 0, and then I'm incrementing by steps of 50. So as a result, I get fewer overall repetitions, right? It takes I less time to reach width if I increase by steps of 50 every time. So oftentimes we're going to write for loops, and we're going to want to make use of the counter inside the loop somehow. Okay, so here I'm using the counter to create x coordinates that increase over time. Or we could choose to assign, the counter to the diameter of the circle. I could say, I could just put the variable straight up, see what happens, right? Oops, I have to actually use the diameter variable over here. So now I could go from 0, right? So that's kind of a tiny circle. Let's put 1 plus. We have a dot here, right? And then really quickly, the x coordinate becomes the diameter, or we could do all kinds of like manipulation if we wanted to. We could divide this by something so that it's not as crazy, right? So we could do that. And this is fine. There's nothing wrong with doing things this way. However, oftentimes we're going to want to be a little bit more deliberate. We might want to say, I want the first circle to be over here and the last one to be maybe over there. And I have a very specific range of sizes I want to achieve. I don't necessarily maybe want to have it tied to the width. Like here, if I'm changing the width of my window, I'm getting more circles, right? It could be what we want. It could not be what we want. So in addition to practicing for loops, we're also going to introduce a function called map, which is basically a number translator. And it's going to be very useful to allow us to take this loop counter, I here, and sort of massage it into different ranges of numbers that might be a little bit more convenient for us. It's also going to allow us to set up our for loop in a way that is not going to rely on tweaking the increment to get what we want, but maybe just focus on the number of repetitions we want and then work with the variable I and map within the loop to achieve the end result. So I'll explain what I mean by this in a second. But first, let's introduce this map command separately, just so we don't get too muddled. So I'm going to do select this, Control// here to comment it out temporarily, and we're going to introduce the map command. So map is kind of a number converter tool. It allows me to so let's say we were to draw. Let's create a variable x here. And we're going to make it equals to mouse x for now. Right over 2, kind of similar to what we had before. And then we're just going to draw a circle, okay, just to demonstrate what map is doing. So now I have a circle that's following the mouse position. Okay, it's going from 0 to width, because that's the range that mouse x takes in this program. Okay, by definition, my cursor can go all the way to the edge here, which means that mouse x has a value of 0. And it can move all the way here, which means mouse x has a value of width. Okay? And it can have all the values in between. So with map, what I can do is I can say, take mouse x, okay, put it into this function. We're going to tell the map function what are the boundaries of mouse x, what is its range in our program. So here its range would be 0 to width. Okay? And we're going to translate that number into a number that is the same proportion, but has a different range. Okay, so let's demonstrate. It'll make more sense. So the map command is called map like this, and it takes 5 parameters. The first one is the number we want to translate or transform. So we're going to put in mouse x as the input number. Okay? The next 2 parameters is map is not particularly smart or anything like that. So we have to tell it, okay, well, this number mouse x you're giving me, what's its range, right? What's the smallest value I can expect? What is the biggest value I can expect in this program? In that case, it goes between 0 and width, okay? Because mouse x, this is the range that it can vary within. Okay? And then the last 2 parameters are going to be, what is the range you would rather get for this mouse x value, right? Maybe we want to shrink it, maybe we want to make it bigger. So for example, we could say instead of 0 to width, maybe I want to go from like 200 to width minus 200, okay? Just to demonstrate, okay? So now I'm specifying a new range. Okay, so let's put map here. So we have the input and the input minimum and maximum. So we have the first 3 numbers are like, what do we give map to work with? And then the last 2 numbers are going to be, what is the new minimum and maximum you would like me to use for the range of the input? Okay. So now you can see the difference. We've mapped mouse x, right, which goes from 0 to width, to a new number, which instead goes from 200 to width minus 200. Okay? But it's going to vary within this range at the same, using the same proportion as the original number. And the result goes into x, and then we draw a circle using x. So now when mouse x equals 0, the map function gives me 200. So my circle is at 200. And when mouse x equals width, the map function returns width minus 200. Okay? So I've effectively changed the range of mouse x in the program. Okay? I've taken what was primarily before a number going from 0 to width, okay? And I've changed this range to go from 0 to width minus 200. We can apply the same idea to anything else, right? I could map mouse x to a range of diameters between, let's say, 100 and, oh, this is the y coordinates, sorry, to a range of diameters between 50 and 100, okay? Let's say. And we're going to use diameter here as our input and height divided by 2. Okay? So we can translate mouse x. We're always going to give it the same input, right? So this is the range of mouse x. This is the range of the number that's going to come out of map. So now I can go from, let's say, let's make this a little bigger, 300, okay? I can not only change the x value, right, to have a different range. I can go from a circle that has a 50 diameter to a circle that has a 300 diameter. Okay? So using map, we can take numbers as input, and then we can massage them, translate those changing numbers to have a new range of variation that serves our purposes a little bit better. So it's a number translator tool, and it allows you essentially to treat things like mouse x and mouse y as sliders, right? That you can move back and forth, except now you get to decide what the range of values you will get out of it, as opposed to always get the full width of the window or the full height of the window, which is not always what we want. The other cool thing with map is we can also reverse this relationship very easily. We could say start with a big circle, okay, and end with a small circle, even though mouse x is increasing as I move to the right. Okay, so I'm increasing mouse x, right? But with map, I can sort of remap this number to have a different start and end point to serve whatever I'm trying to do in the program a little bit better. So we can change the range, and we can easily also reverse that range just by starting with a bigger number and ending with a small number. Okay? So it's a very useful little function that we can use to apply to any number, not just mouse x and mouse y, but these are very convenient ones we have access to. And as we're about to see in a second, we can use map to take our loop counters and sort of transform them into numbers that have arbitrary ranges based on what we're trying to do. Okay? So let's put that aside and go back to our for loop example, and we're going to throw in a map in there just to demonstrate how useful it is. Let's just tidy the code instead. Okay. All right. So with map, what we can do is, instead of setting the number of repetitions to be, let's say, based on the window size, okay, we're going to take a different approach. We're going to create a variable, let's call it n, and that's going to be the number of circles we want to draw. So I always want to draw 10 circles, which means we are going to do increments of 1, and we are going to repeat as long as I is less than n. Okay, and of course, if we do this, I have tiny little circles here that go from, x value 0 to 10. Okay, so this is not very practical. But the one thing that this allows me to do is very clearly define a for loop that repeats 10 times. So I know I want to draw, let's say, 10 things. I can approach it that way. And now what I can do inside the for loop is I can use map to take the counter and kind of massage it to do what I need it to do. So here, for example, excuse me, we could say map the number I, which we know as the loop repeats, is going to go through a range of values, right? What is this range? Well, it's going to go from 0 to n minus 1. Okay? So it doesn't quite go to n because we use the less than sign, which means if our loop repeats 10 times, in this case, I will count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it will stop because I will no longer be less than n, which is 10 here, okay? So n minus 1 is the end of that range. So this is the kind of the setup part for map. We're going to say, what's the number you want to map? I. What's its range? 0 to n minus 1. And then what's the range you would like me to give you instead? Well, in this case, let's say I want to have circles that go from x equal 50 to width minus 50, okay? Or just start with 0 and width to begin with. You just make it clearer. So now I have circles that go from 0 to width. Their diameter is still very tiny, so I'm just going to put a 50 pixel diameter, okay? Or 100, whatever. So we can see now we have exactly 10 circles. Okay? 10. And this is going to follow the size of my window, right? So regardless of the size of the window, I now have 10 repetitions. And every time the loop repeats, my counter I, right, I'm using it to draw a different circle, and I'm using map to sort of calculate for me the x coordinate of each of the circle in the loop. So very convenient. We could adjust this range as needed, right? I might want to say, how about I get these circles to start at 100, okay? Maybe end at width minus 100. Right? So this is now very easy to manipulate this range of values. Maybe I wanted to have an increasing diameter for whatever reason. I could map I, which we know goes from 0 to n minus 1. I could map it to, I don't know, an arbitrary range, okay, 50 to 400. So now, or I don't know, maybe 200. Okay. So now I have increasingly large circles because as I repeat my for loop, as I draw more circles, my variable I increases. However, because of map, right, I can transform that number into any other number range that I want to. Or I could reverse this relationship. I could say go from 300 to 100 instead. Okay? So this is a very flexible tool. Okay? It allows us to free ourselves from having to do the math ourselves, which I'm sure most of you agree is a good thing. It's a desirable thing. Okay? So we're going to explore map quite a bit more this semester, but that is the general idea. Now, I want to talk about one more thing here before we move on, and is the idea of the loop and no loop functions in the language, because since we're talking about loops this week, these can get a little bit confusing. And let me demonstrate what I mean by this. Instead of mapping the counter to create the diameter here, we are going to create a random diameter. Okay, so I'm going to go random, and let's say from 50 to 250. Whoa, okay. So this is pretty intense, right? And that's because, remember, we're in draw, okay? And draw repeats over and over. We erase the background, and then each of the circles is getting a random diameter. So this is just really completely all over the place, very frantic. Okay? There is a command in the language called noLoop, and you might run into this. This has nothing to do with the concept of for loops or while loops. What noLoop does, it pauses draw. Okay, so this, I just want to point it out because oftentimes students will see this in the reference and get confused by it. So noLoop pauses draw, and let's say we define key pressed. You know, we could say key pressed loop. Okay, so this is start draw again, and this pause draw. Okay. So they're very kind of awkwardly named commands, because in my mind, a pause and on pause would have been maybe more intuitive, but this is what they do. Okay, so these, even though they use the word loop, they're not related to the concept of loops as we've talked about in class this week. Okay, so all this allows us to do is pause the main app and then start it again on demand as needed. Okay? So this way I could say run draw this pattern with some randomness, and then just pause, and then whenever I hit loop again, it triggers draw, which will create another random pattern, and then pause until further notice. All right. Okay. So that concludes what I wanted to cover this week. Yeah, so have some fun with this week's code exercise, and I will see you next time.